All right, the last section for this topic 6 is 6.5, and it says properties of special parallelograms. So we're going to continue to talk about parallelograms, but we can get even more specific than a parallelogram. We're going to talk about rectangles, we're going to talk about rhombuses, and we're going to talk about squares. And the thing about all three of those is they are parallelograms. Okay, so a rectangle is a quadrilateral with 4 right angles. And with a rectangle, we have the right angles, which means the opposite angles are congruent to each other. That's what makes it a parallelogram. So because it's a parallelogram, rectangles are parallelograms, so they have all the properties that we talked about that go along with being a parallelogram. Okay, we have 2 pairs of parallel sides. In a rectangle, these opposite sides are parallel to each other. In this rectangle, these opposite sides are parallel to each other. Okay, we also know that we have 2 pairs of congruent sides. In a rectangle, these sides are congruent to each other. These sides are congruent to each other. Opposite angles are congruent. We already talked about that. These opposite angles are equal. These opposite angles are equal. Okay, consecutive angles are supplementary. Since these are both 90 degrees, 90 plus 90 is 180. That makes them supplementary. Goes this way too. These are both 90 degrees, so 90 plus 90 equals 180 degrees. So they're supplementary to each other. And then the diagonals bisect each other. So when we draw in the diagonals for a rectangle, they get bisected here, they get bisected there. Okay, and we're actually going to look at that a little bit closer. Okay, so because a rectangle is a parallelogram, all 5 of these properties exist for the rectangle. And you're going to hear me say that a lot today. Okay, now, in addition to these 5 criteria or properties for a rectangle, we have some unique ones that are unique to the rectangle. So not all parallelograms have this, but if it's a parallelogram that is a rectangle, then these properties apply as well. It says the diagonals of a rectangle are congruent. So if these distances are congruent to each other, that means those lengths are the same. Because they bisect each other, all 4 of those distances are the same. Okay, so it says find the lengths for the rectangle MNPQ, round to the nearest 10. If this distance from Q to N is 5, that makes this distance up here 5. And that makes this distance 5. And that makes this distance 5. All of them are going to be 5. So it asks me the distance from M to P. M all the way across to P, that's both of them, so that would be 10. M to Q I would have to work out because that is, that's a triangle, so we're going to have to figure out what the distance is. We'd have to do a right triangle here. Okay, so let's just focus in. If I want the distance from M to Q, okay, I know that this is 5 and this is 5. That makes the hypotenuse of the right triangle 10. I pull that triangle out of here. This would be 10. This distance over here from P to Q is 4, so this distance from N to M is 4, and I'm having to find that. That's MQ. So we would have to use the Pythagorean theorem. We would have to say 4 squared plus x squared equals 10 squared. Okay, and then we would work that out from there. Okay, there's not going to be a lot of questions like that. Okay, that's the rectangle. So in addition to those 5 criteria for being a parallelogram, we know with a rectangle we've got 4 right angles, and we know that the diagonals bisect each other, so all sections are the same. Okay, with the rhombus. Okay, rhombuses we don't see as often as rectangles. Rectangles, there's a lot of rectangles out there. But a rhombus is a quadrilateral with 4 congruent sides. Okay, so you can see the tick mark is here for all sides. They're all the same length. Okay, it says that rhombuses are parallelograms. So we have all 5 of those properties that we listed on the previous page. Okay, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. and diagonals bisect each other. And in addition to that, if we have a rhombus, the diagonals are perpendicular to each other. So perpendicular means that we have a right angle there. They're 90 degrees there. Okay. Also, the diagonals of a rhombus bisect the angles of the rhombus. So if you look at the diagonals down here, not only are these diagonals perpendicular, so we've got 90-degree angle there, but these lines bisect the angles. So we've got the same measurement on both sides here. We have the same measurement on both sides there. Same thing here. We have the same measurement on both sides. Those angles in the corners get bisected. Okay, so they ask us a question here. They say quadrilateral ABCD is a rhombus. Since it's a rhombus, all four sides are congruent. The diagonals are going to form a right angle here. It says, what is the measure of ADE? From A to D to E. It's asking for this measure right here. Okay, well, if this is 53 degrees up here, I know that this is 53 degrees down here because that diagonal is bisecting the angle of the rhombus. Okay, that's what we talked about up here. So this has been bisected. It's 53 on both sides. So I'm going to redraw that rhombus. This is A, B, C, and D. So if this angle, if I'm going to take the diagonals out, 53 plus 53, that's 106 degrees for that full angle. And if a rhombus is a parallelogram, then I know that these two angles are going to be supplementary. They're consecutive. So what do I have to add to 106 to get to 180? Hopefully you said 74 degrees. Okay, if I add these two together, I get to 180. So if this angle down here, this whole thing is 74 degrees, what's that portion that I want, that A, the measure of ADE? Well, it's going to be half of that. So 74 divided by 2 is 37 degrees. This angle right down there is 37 degrees. Remember that the diagonal bisects the angle. So if the whole angle is 74, bisect means to cut it in half. I get 37 degrees out of that. Okay, it says quadrilateral GHJK is a rhombus. What is the distance from G to H? Let's see, what can we do here? We know that all of those are the same. So this is going to be, do I have enough information here? I might be missing something here. I know that since the rhombus is a parallelogram, that the diagonals bisect each other. So what do I know about this distance and this distance? If they bisect each other, that means these are congruent. So I would say 2x plus 3 equals, gotta go back and see what that says, 4x minus 7. So I can write an equation. I do have enough information. These are going to be equal to each other. So when I solve this, I subtract 2x from both sides. So 3 is equal to 2x minus 7. I'm going to add 7 to both sides. 10 is equal to 2x. So x equals 5. Now that doesn't answer the question. The question says, what's the distance from G to H? So I need to go up here. G to H has one tick mark in it. So it's going to be the same as this one that has one tick mark in it. And that says 3x plus 1. So if I plug my value for x in, I get 15 plus 1. That distance is 16. Okay, that's what we know about the rhombus. Okay, we know that the diagonals are perpendicular, and they are the diagonals get bisected just like any parallelogram. The last type of special parallelogram is going to be the square. Okay, and what's really unique about a square is a rhombus. Okay, the definition of a rhombus was that a quadrilateral that has 4 equal sides, 4 congruent sides. Well, a square has 4 congruent sides. So it is a rhombus, meaning those two characteristics, the fact that the diagonals form a perpendicular and the diagonals bisect the angles, that holds true for the square as well. A square is also a rectangle. Okay, the definition of a rectangle was a quadrilateral with 4 right angles. Okay, a square is a quadrilateral with 4 right angles as well, so it is a rectangle. Okay, so that means the characteristics for the rectangle also apply to the square. The square kind of gets all of those properties. It says a square is a quadrilateral with 4 right angles and 4 congruent sides. Squares are parallelograms, so all the properties of parallelograms apply. Hopefully you're reading this on your... Okay. Squares are parallelograms, all the properties apply, so it has 2 pairs of congruent sides, it has 2 pairs of parallel sides, opposite angles are congruent, supplementary or consecutive angles are supplementary, diagonals bisect each other. It says squares are also rectangles, so they have the properties of the rectangle, meaning the diagonals bisect each other. Notice they all have 2 tick marks, so that means they're all the same. Okay, what else do we have? It says squares are also rhombuses, so they have the additional properties of the rhombuses too. Okay, so the diagonals of a square form a perpendicular and it bisects these angles. Okay, so you use those, nothing unique to just the square. The square, all the rhombuses, all the rhombus properties apply and all the rectangle properties apply. So when you're answering your questions, it says find each length and angle measure for the square. Okay, this one wants angle YPZ. So here's Y to P to Z. Okay, well remember that because it's a rhombus, the angles where they intersect, that's a 90-degree angle. This is going to be a right angle, so that's 90 degrees. It says find the measure of XWP. X to W to P. Okay, so you see up here that the diagonals bisect. This diagonal is bisecting that, and that's a right angle if it's a square, so half of 90, that's going to be 45 degrees. Okay, and then the distance from X to Z, from X all the way across to Z. Well, if this is 7, this is 7 also. Okay, the diagonals bisect each other, so all the way across would be 14. Okay, if you want kind of a summary of all the different properties, you've got a good look down here. You're going to use that information, and again, don't forget that we're looking specifically at parallelograms and types of parallelograms. So we had 5 different characteristics or properties of a parallelogram, and then in addition to that, the rectangle, the rhombus, and the square are all types of parallelograms. And in addition to those 5 properties, we have some unique ones for each one of those. Okay, so you got to put that all together and start working on worksheet 6.5.